All right. We know that isosceles triangles are triangles that have what? Two congruent sides, at least two congruent sides. The sides that are congruent are called legs, just like a right triangle has legs. An isosceles triangle does as well. Those are the sides that are congruent. And the side that is not congruent, so the third side, is the base. All right? So now let's talk about angles. The angle in between the two congruent sides is called the vertex angle. And at the base here, on either side of the base, you have two angles. So let's focus on this angle. What two sides is it formed by? It's formed by the base and one of the legs. That's called a base angle. Here we have another one formed by the base and one of the legs. That's called a base angle. So these are the characteristics of an isosceles triangle. Two sides are legs, the congruent sides are legs. We have a base, we have two base angles, and a vertex angle. All right? Now, here's an important theorem. It's called the isosceles triangle theorem. So it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right, so here you can see that you have two sides that are congruent to each other. If that happens, then automatically the two angles opposite to them are also congruent. So if we call this side 1 and if we call this side 2, this angle C is opposite to side 1, right? It's opposite to side 1. And this angle A is opposite to side 2. Those are congruent. All right, look at this problem here. It says to find x. We have a isosceles triangle, and we're going to use the isosceles triangle theorem. If two sides are congruent, then the angles opposite to them are congruent. So the angle opposite to this side is this one. The angle opposite to this one is this one, and those are congruent to each other. Meaning, if the one on the right has a measure of 3x plus 8, then this one is also 3x plus 8. Now, we have a third angle, which is 2x plus 20, and we know that all three of those angles add up to what? 180. So we have 2x plus 20 plus I have two of these angles, 3x plus 8, and those equal 180. Yes?
Can you go back to how you found how the top two angles were congruent?
Right. So if you have two sides that are congruent, the angles opposite to them are congruent. So if you look at this side here, the side opposite to this, the angle opposite to this is that one, and the same for the other. So back up here, you know, for the sake of completeness, if AB and CB are congruent, then angle A is congruent to angle C. So if my triangle was oriented a different way, if this is angle A, B, C, and now I have these two sides congruent, which two angles would be congruent? Angle A and angle B. Okay? All right. So back to this problem. It's just the algebra we have left. We have 2x plus 20 plus 6x plus 16 equals 180. So 8x plus 36 equals 180, meaning 8x is 144. And x is 18. Okay? So that's how we find x. All right, this next one, we have, okay, so let's mark down what we have. GH is congruent to HK. So GH, HK. You see how I don't even move on before marking the diagram at each and every single step. HJ to JK. So HJ to JK. Angle GJK is 100. And we want to find HGK, this one. All right, we've got lots of isosceles triangles here, right? Well, at least two that I can see. Okay? So, if we just look at this a little bit closer, let's see what we have. Look at this triangle here. Triangle HJK, so this one. It's an isosceles triangle, right? Meaning this angle is congruent to that angle. Is that right? Yes. Because I'm just looking at this triangle. And if side HJ is congruent to JK, that means the base angles there are congruent. So now, if this is 100, right, and we subtract from 180, then I have how much left? 80, which means each gets 40. So 40 for this, 40 for this. Now, if that's 40, what sort of situation do I have here? It's a linear pair. That means angle GHK is 140. And now this other triangle, GHK, is also isosceles. If the two sides are congruent, that means these two angles here are congruent. Meaning, if the big angle is 140, how much does that leave for each of these smaller angles? 20. That means angle HGK is 20. All right, so the trick really is to not get overwhelmed, divide and conquer, okay? Split it up into little compartments that you know how to solve, and then continue from there. Okay, look at this one. Now it tells you triangle ABD is isosceles, and B is actually this one here. It got left out of the diagram. B is it's isosceles. Triangle ACD is a right triangle. Measure of angle 6 is 136. What is measure of angle 3? Okay, so here we have to use the fact that we have an isosceles triangle. Okay, so if this is 136, we know that these two angles are congruent to each other. So I say 180 minus 136 is equal to 44. And if I divide that by 2, then angle 4 and angle 5 each get 22. Now, right, so here we have a 90-degree angle. So measure of angle 3 plus 22 equals 90. That means measure of angle 3 is 68 degrees. Okay. All right, so here we have a proof now. All right, we have given triangle PQR. PQ is congruent to QR. This is a proof of theorem 4.9, which said that if two sides are congruent, then the angles opposite to them are congruent. Okay? So what we want to do here is we want to prove that angle P and angle R are congruent. So let's see how we can do this. strategy here is we're going to draw another auxiliary line. We're going to use HL, but to do that we have to create right triangles in here. Okay? So, sorry? Oh, it's the line that you introduced to the diagram. That's a line that you put into the diagram. Yes? But that's what you're trying to prove. You cannot use a theorem that you're trying to prove in your proof itself. So here we have PQ congruent to QR given. Number 2, okay, what I'm going to do is I'm going to add this auxiliary line there, okay, at S. Right, so I would never give you this problem to solve on a test. We do it in class so you know. So you know, for example, in order to prove the triangle sum theorem, you have to add an auxiliary line. In order to prove this theorem, you have to add an auxiliary line. You basically just sort of learn them, okay? That's really it. Okay, so if I asked you to reproduce this theorem on a test, I'm sorry, this proof on a test, then you would just mimic what we did. Okay. So here, we're going to say QS is perpendicular to PR. And this is a challenging proof. This is why we're doing it together in class. And now this was a postulate that we learned that said the shortest distance between 2 points is a perpendicular line, remember? Yeah. So shortest distance is a perpendicular segment. This was a postulate that we learned. Number 3. All right, so if we have a perpendicular line there, then angle QSP and angle QSR are right angles. And the reason is because of definition of perpendicular lines. Okay. What I want to do here is I want to use HL, okay? So we want to use HL because we now created right triangles. That means I have the hypotenuse congruent. I need one of the legs to be congruent, okay? So I need a leg. All right, so I need congruent legs. So QS is congruent to what? Right. Reflexive. If you're going to use reflexive, you have to keep them the same. Okay, so now what I have here is, this is the hypotenuse, right? Here, now I have a leg, okay? And since I have the 90-degree angle, I can say triangle PQS is congruent to triangle RQS, again, HL. And next, how do I prove angles are congruent? Right. Okay? I love CPCTC proofs. So here we go. We just proved that theorem. All right, so we're skipping this proof for now. We're going to come back to it later. Let's go to theorem 4.10. He didn't hear you. All right, so this is the converse of the isosceles triangle theorem. Converse means we're going in the opposite direction. So before we said if you had two congruent sides, then the angles opposite are congruent. Now we're saying if you have two congruent angles, then the sides opposite are congruent. That's why it's called the converse of the isosceles triangle theorem. How utterly appropriate. Okay, so meaning, but it's brownie points for you for recognizing that. 2 brownie points for recognizing it, minus 4 brownie points for not paying attention when I said it was the converse. Okay, so if angle D is congruent to angle F, then the opposite sides, right, are congruent to each other. So DE is congruent to FE. Okay? And if you get confused, FE, where did G come from? And if you get confused, just remember that if you have the 2 congruent angles here, this is the included side. All right? This is the included side. The included side is always the base. Okay, so if you get confused, just think of it that way. All right, let's go to the next page. We have a diagram here. We want to name 2 congruent angles in triangle ABD. So we're in triangle ABD right here. 2 congruent angles in triangle ABD. Anybody have any ideas?
Yeah.
Which ones? Okay, so give me the names of 2 congruent angles in ABD.
I know that middle point is called
Jesse.
ABD and angle ABD.
Right, so it's this one and this one. Okay, so angle ABD is congruent to angle ADB. Right, so if you look at the triangle that I've highlighted, you have an isosceles triangle because these 2 sides are congruent to each other, meaning the opposite angles are congruent. So here it says name 2 congruent sides in triangle BCD. Now I'm in this one, BCD. Okay, if these 2 angles are congruent, the included side is the base, meaning the 2 opposite sides are congruent to each other. So it's BC congruent to segment DC. All right. Here we have a couple of corollaries. Remember what corollaries were? These are corollaries are statements that you could just come up with based on a theorem. Okay? So a triangle, it says, the first one it says, a triangle is equilateral if and only if it is equiangular. Okay? So equilateral means the sides are congruent. And equiangular means all the angles are congruent. So if all the sides of a triangle are congruent, then all the angles are congruent. This is based on the isosceles triangle theorem. Yes? Yes. Each angle of an equilateral triangle measures how much? 60. We've been over this a couple times now. All right. Next one, example 7. If triangle EFG is equilateral and segment EH bisects angle E, right? Then we have to find what we are given here. So the fact that it's equilateral means all the angles are how big? 60, 60, and this together is 60, right? Now, if H bisects angle E, what does that tell us? What's congruent? Angle 1 and angle 2 are congruent. So we never want to use pronouns, right? They, it, this. Always use the actual names. The angles are congruent. Angle 1 and angle 2 are congruent. Be as precise as you can. That means how big is angle 1 and how big is angle 2? They're each 30 because since this is an equilateral triangle, this entire angle would have been 60. So measure of angle 1 equals measure of angle 2, and they both equal 60 degrees. 30 degrees, sorry. Next, it says to find x, okay? So if I just focus on this triangle to the left, if this is 60 and that's 30, together they make 90, which means 15x is equal to 90, so x is equal to 6. Okay, yes. Right. That doesn't mean that they're perpendicular. Bisecting doesn't mean right now that it's perpendicular. Okay. This is the proof that we hadn't completed in section 5. We're given this diagram up here. We want to prove, yeah, it's very similar to that one, okay? So we want to prove that this is congruent to this. Okay? What I do first is I want to prove that the triangle on the right and the triangle on the left are congruent. Okay? When I do that, the second step is to prove the big triangle here and the big triangle here are congruent. Okay? So, should I continue or start this all over? How are we doing here? Okay. Okay. Okay, so we're starting the proof all over again. We're told that AB and DC are parallel and they're congruent. And we're told that AB is perpendicular to BC right here. We're also told that E is the midpoint of these two lines. And we have to prove that the blue and the yellow line are congruent to each other. Okay? So the big picture is I have to prove these huge triangles are congruent to each other. And then I could say the colored sides are congruent by CP/CTC. And we're going to start slow. All right. The fact that I'm told that E is the midpoint of AC and BD tells me that I have sides that are congruent. So namely, AE is congruent to EC and BE is congruent to ED. So that's my number 2 here. AE is congruent to EC. BD is congruent to, BE is congruent to DE. This one is midpoint theorem. Now, next, there is an angle here congruent to an angle here because of vertical angles. So I say angle AEB is congruent to angle DEC. Vertical angle angles are congruent, or you can say vertical angle theorem. All right, now look at what I have here. I have here sides that are congruent, right? So here is a side, here is another side, and an angle in the middle, so this is SAS. Okay? So those two triangles are congruent by SAS. So I say triangle AEB is congruent to triangle CED, SAS. Congruence. Okay? Now, that means that AB, all right, that means that AB here and CD are congruent, right? So these two on the edge are congruent because of CPCTC. Any questions so far? Okay, so now we've said that those two sides are congruent. Next, I now want to prove that the big triangles are congruent. So how are we going to do that? Well, to prove that the big triangles are congruent, here there is a side that's being shared. I say BC is congruent to BC, reflexive. Okay? Now, what's the measure of this angle here? 90 degrees, right? So I say, well, I know that angle ABC is a right angle because I know that it's perpendicular. So perpendicular lines form right angles. Now, how about this angle C? Do I know that this one is perpendicular? Why? Right, so here I have parallel lines, and BC is a transversal to the two parallel lines. If a transversal is perpendicular to one parallel line, it's perpendicular to another parallel line. So I can say So I can say over the BC is perpendicular to DC. This is the perpendicular transversal theorem. Yeah. Now I can say angle DCB is a right angle. I could have combined those two. 7 and 9 could have been combined, okay? So this would be perpendicular lines form right angles. Now, what do I have here? I have a side, another side, and an angle in the middle, right? Have I said that those two angles are congruent? Not yet. So now I say angle ABC is congruent to angle DCB. Why? Why? Right, and the theorem is all right angles are congruent. 11. Now I say that the two triangles are congruent, right? The two huge triangles. So what's one of them? It's triangle ABC is congruent to triangle what? DCB. Because of SAS. And now that the two huge triangles are congruent, any side that you want on each of them are congruent. So we say AC is congruent to DB, CPCTC. Okay?